Yeah, hello students. Greetings of the day. This is your Eknath sir. Let us see this following questions now.
Zero. So
Okay.
which option is correct? You have to
Yeah.
click.
So here
Once
we are
think about
having
this question, two
a
minutes,
magnetic
everyone.
field is there. Okay. And a
Fifteen
particle is
minutes.
projected from
What is the
point
question
P.
given?
It is
So
reaching
the
point
PV and
Q.
electric field
And
along
the following
x-axis,
options
magnetic
now.
field along
Okay. Look
positive
at it.
z direction.
Yeah.
PK gap given. The particle with charge q and mass m moving under the influence of uniform electric field EI and uniform magnetic field PK gap follows a trajectory from P to Q. It's following this kind of path. P to Q. P velocity is x direction, q velocity is downward along y direction, negative y direction. So the velocities at P and Q are given like this. So that is asking, so going from P to Q, questions is framing. So electric field magnitude, okay, rate of doing work of electric field, rate of work of electric field at P 0, rate of doing work, rate of doing work at P by both electric field and magnetic field is 0. Okay, yeah, చెప్పండి ఏమో సాంగ్స్ చెప్పండి. And this length path also given here. This point P at distance A, this point is at P. Trajectory, huh? This value is A given, this value is given as 2A. They're not circular path another. Isn't it? Keep in mind some curve kind of thing. If it is circular path, what happens? This two will be equal. Yes or no? And magnetic field everywhere what? So velocity direction this point is like this, magnetic field is perpendicular, it's coming like this. Okay, and here also magnetic field is perpendicular only. Electric field is here how? Electric field is here tangential. So here what? Electric field is in this way, magnetic field this way. Angle is 90 degrees. So at point Q, electric field is perpendicular. Magnetic field also perpendicular to velocity. At point Q. At P, electric field is parallel to velocity. Magnetic field is what? Perpendicular to velocity. So you have to think and answer this question. Now, so what is magnitude of electric field? You have to find out. In going from P to Q, if we consider who is doing work here, is there any change in kinetic energy? Magnetic force is what? Perpendicular only at P and Q. At P also magnetic field perpendicular, at Q also magnetic field is perpendicular. So magnetic field will not do any work. Why? Force and displacement allow nine, perpendicular nine. So what is the work done will be zero. So will there be any change in velocity because of magnetic field here? There will not be any change in velocity because of magnetic field. Why magnetic field is not doing any work? If at all magnetic field if it is doing work, there will be change in kinetic energy. Yes or no? So if change in kinetic energy there, but it is not because of magnetic field, because of whom? Because of electric field. Why this charge of the particle is here Q? So fine. Now here, I don't know, at point P and Q, at points P and Q, writing question over everyone. Writing question over everyone. Now electric field is along x-axis, magnetic field is along what axis? Positive z direction. Now first question you have to find out. Now so before this, let us consider some conclusions here. Now at P and Q, okay, magnetic field is perpendicular to what? Velocity. This clear or not? If velocity is like this, magnetic field is in this way. At Q also velocity is downward, magnetic field is like this. So work done by magnetic field. Okay, work done magnetic field in P to Q. There is no work is done here. At P and Q, what happened here? No, magnetic field is not done any work. Okay, that is equal to 0. Now, so here who is doing work in going from P to Q? Electric field. How much magnet of electric field is? Mindra. Magnetic field electric field is how much? E that is given. So that is E into I cap we mentioned. Okay, so charge particle is Q. How much electric force will act here? Electric force is equal to QE acting, isn't it? So electric force is equal to Q into E. Direction of force, direction of the field. Field is along x-axis, so force also along x-axis. F is equal to Q into E. Now what is velocity at P? Velocity at P is equal to V. I cap. Velocity at Q, how much rate? 2V, of course, J cap, but we want for kinetic energy magnitude. So here magnetic field is not doing work, only electric field is doing work. So direction of electric field is like this. When it is moving P to Q, how much displacement along electric field is here? Displacement along electric field how much? 2A. Yes or no? Therefore, work done by all the forces is what? By work energy theorem. By work energy theorem, work done by all forces equal to what? Changing kinetic energy. In going from P to Q, magnetic field is not doing any work. Electric field is doing work. So, what done by electric field is what formula? So force into displacement is equal to change in kinetic energy. Half into m into v square minus u square. Velocity at this point is 2v, at this point is v. Change in velocity square, v square minus v square. 4v square minus, at this point velocity how much? V. So how much will have now? Electric force is E into Q. Displacement along x direction of the particle is 0 to Q now. Q along x axis how much displacement it is? 2a. That is equal to 2a is equal to half m into 3v square. So what you can write down now? Just step by step. Yes, right. Or Q into E direct, no? Is asking what value electric field magnitude is asking. Electric field magnitude. So we are getting in terms of charge, we are getting no. It by question is 4 mv square by QA should be here. A option 3 by 4 mv square by QA. Now we want the value of E. This is equal to this is 3 and 2 to the 4. 3 by 4 mv square by QA. Therefore, magnitude of electric field how much now? 3 by 4 mv square by QA. I forgot it writing here. Please write down this one. Okay, first option is matching. So now I'm doing work from P to Q. Electric field is doing work and magnetic field is doing 0 work. Next, rate of work done by electric field at P. At P, electric field work done. So how much here now? At P, actually velocity direction only. Direction only. And force also in the same direction. Isn't it? So what you can find out being work is called what? Power, no? Yes or no? Rate of doing work is work by time. Is called what? Power. Therefore, power P is equal to work done is what? F dot S by T. No, only a point P is asking. Specific, not as a whole is not asking. As a whole, it is initial velocity in the direction of x-axis we are taking. No, not that displacement. Work done by electric field. What done by electric field? Electric force along x-axis. Displacement along x-axis how much here? 2a. That's what I have said. What force into component of displacement direction of the force. If you want to take this also, you can take. If component direction is column. And this is angle already electric field x direction. Let's just see x, how much direct displacement x direction. Displacement x direction is 2a. That's why into 2a direct. What am I electric force in going from P to Q? Now, so here rate of doing work is power. So that is F dot S by T is V. F dot P. F at point P, F is E2 in the same direction, velocity is the same direction. Theta is equal to 0. Path delay is 1. Simply F into V. F value how much? F value is EQ at this point P. This is point P. Force is EQ. Into velocity instant is V. So this is the work done by electric force is EQV. But it's saying rate of doing work electric field is 3 by 4 MdQ by A is saying. So E value how much? E value is up to here. 3 by 4, how much? mv square by qa into qb. So q get cancelled. What left, right? 3 by 4 mvq by a. Is it matching? 3 by 4 mvq by a. Yes, this is the what? Work done by electric field at point P. The rate of the work, power at point P. Okay? Power at point Q, how much now? 3 by 4 mvq by a. So this option also matching. Next. Rate of work done by electric field at P is 0. No, this is not. But because velocity is not perpendicular to electric field. Now, rate of doing work at P by both electric field and magnetic field. Okay, at where? At P is 0. Is it true? At P or Q is saying rate of doing work at Q. Sorry, this is at Q. Rate of doing work at Q by both electric and magnetic field. At Q, velocity is downward. Magnetic field is perpendicular. Work done is 0, so power is 0. But whereas velocity is downward, electric field is what? Horizontal. Again, for electric field also how much angle here? 90 degrees. So work done our power value F dot B, you can say. F dot B angle is 90 degrees, no? F dot B. So what is work done by electric and magnetic field both at point where? Which point? At point Q is how much? Is equal to 0. Therefore, so this option is what? This option is correct only. Zero. Yeah, this is correct only. So 1, 2, 3 options are correct. This is what work done by electric and magnetic field when a particle moves a curved path, follows a curved path in what? Simultaneous existing electric and magnetic fields. Okay. Done everyone virtually people. అర్థమైంది అందరికి?
Yes, sir.
Here I one more question, right? Electron at rest are accelerated. Electrons at rest are accelerated by a potential of V volt. This part writing over everyone, students. Rate of being work by electric field is power F dot V. Here F into V was same direction, PQ, but P value is found here. 3 by 4 mv square by q. Substitute this 3 by 4 mv by a ochina. Yeah. So next question, write down. Electrons at rest are accelerated by potential of V volt. Electrons at rest are accelerated by potential of how much? Potential of V volt, capital V volt, full stop. These electrons enter the region of space. These electrons enter the region of space having a uniform perpendicular magnetic field. Enters a uniform what? Enters the region of space having a uniform perpendicular magnetic field. Perpendicular magnetic field. Full stop. The radius of the path of the electrons. The radius of the path of the electrons inside the magnetic field is. The radius of path of the electrons inside the magnetic field is. Yeah. So answers are in terms of electric field, magnetic field, mass, magnetic field, and velocity rate. The first option is root of mVV by BE. First option root of mEV divided by B charo. B. B bar, of course, magnetic field.
No, not B. Question.
B capital V, velocity, potential, sorry, potential difference is V.
Yeah.
Capital V it is. Potential difference V.
Yeah.
Pardon?
That's what I was saying.
Yeah, fine. Got it.
Yeah.
You are saying bold, capital letter you are saying.
No,
See, electrons are accelerated. See, when you apply some potential difference, what happens? Electrons accelerate, no. That value they mentioned is capital V is potential difference here. Magnetic field is B. Charge of electron is V. Mass of electron is what? Capital M. Okay? Yeah. So electrons at rest are accelerated with potential V volt. These electrons enter the region of space having uniform magnetic field B, capital B. Full stop. The radius of the path of the electrons inside the magnetic field is given by root of MEV divided by BE. Second option is root of 2MEV. 2MEV divided by BE. B into E ray. And third option is given as root of MPV. In mass of the electron, you can say capital M or small m only. You can take everywhere small m ray, not capital M. You take everywhere small m. Okay. Root of MEV divided by 2BE. And fourth option is given as none. So no option is matching is given. So right, think about this question. All of you know how they are entering the magnetic field is mentioned. No? How they are entering perpendicularly, isn't it? So they enter perpendicularly. Stream of electrons. Say electrons are entering like this. Magnetic field you can say into or outside, doesn't matter. Perpendicular of it. Okay? You can take into or outside. So this is negative charge. So this charge is equal to Q. If it is positive charge, velocity of the electrons is V. V cross V. Positive charge they have got experience force upward. So negative charge they get experience force in what direction? Downward. Yes or no? And we have seen when experiencing downward force, so when they are entering this particular magnetic field is pointing into the board or outside the board, say I'm taking into here. So when positive charge is going this B cross B, positive charge will have experienced force upward. I'm taking magnetic field into. Negative charge will be up downward. So when they are entering, so they will tracing what kind of path? Circular path. Or formula of the radius of circular path R is equal to mb by bq. What is v here? These velocity. But what is saying? These electrons are accelerated by some potential difference. Okay, like we have electron gun is there here like this. Okay, so by thermionic emission, electrons will be emitted here. These emitted electrons when it creates some potential difference. This is cathode, you can say negative. This is anode, you can say positive. So when they accelerate some potential difference here, this is high potential, low potential. Electrons are accelerated. While accelerating, okay, they are entering into the magnetic field. So how much potential difference here? V. So how to relate now? The kinetic energy of electrons or work done by this electric field is changing kinetic energy by work energy theorem. So what you can write from here? So the kinetic energy gained by the electrons, kinetic energy gained by the electrons is equal to work done by electric field here. V is equal to W by Q formula. V is equal to W by W how much? V into Q. So same potential is work done per unit charge. So work done is equal to charge into potential difference. So change kinetic energy gained by the electrons. Some constant velocity entering half mv square is equal to charge of electron is the potential difference is v. Therefore, velocity of the electron how much now? 2ev divided by m. Okay, this in chemistry also study this formula. This are no in physics you should know very well. Kinetic energy, work energy in application. Velocity not you simply find out your radius now. Therefore, radius r is equal to what we have m by bq into what is velocity? Velocity is 2ev. But here velocity is what? 2e by m under root. In b square no, b becomes root. Therefore, root of 2ev by m. So when you take this one and inside if you take this one, right, root of 2 is m square by m becomes m 2m ev. Okay, divided by charge is e no, so b into e. Therefore, we have how much now? How much we have? The work done by this particular potential difference is accelerating the electron. So from this work energy theorem, half mv square is equal to ev. We are finding the velocity. Once you got the velocity, what radius they will trace in the magnetic field? The value of r is mv by bq. So bq is e, q is e, velocity is root of 2 ev by m. Sometimes so many times in modern physics, this itself is asked. Electrons are accelerating the potential difference of v volt. What is the velocity? V is the direct formula. Root of 2 ev divided by m. So which option is matching? Second option is matching. Yeah. Over everyone writing? And one more question. No? Find. Chindan, not the problem? Anvita. Srividya AD. Ilpina? Online says. Where is the sad? Home. Okay. Yeah. A proton, next question. A proton, comma, a deuteron, and an alpha particle. A proton, comma, a deuteron, and an alpha particle. Deuteron. Proton, neutron, and what? Alpha particle. These three are entering. Okay. Boom. A proton, neutron, and an alpha particle. That is question, right? Alpha particle accelerated through the same potential difference. Pravar, write down. बोलता हूँ देखो. So a proton, a neutron, and an alpha particle accelerated through same potential difference. PD, potential difference, same potential difference. Writing it, everyone. Hello, virtual people.
Yes, sir.
What I'm saying, right? Markem del surrender. A proton, a neutron, and alpha particle accelerated through the same potential difference. the same potential difference, enters a region of uniform magnetic field. Enters a region of uniform magnetic field. Moving its right angle to B. Moving at right angles to B means how they are moving? Perpendicularly. So whenever they move perpendicularly, what kind of path they trace, right? Circular paths. Okay, so moving here, yeah. So a proton, a deuteron, and alpha particle exert the same potential difference, enters a region of uniform magnetic field, moving at right angles to B. B means magnetic field. Right angles to B. Full stop. Capital B. Right angles to B. Full stop. Compare the radii of their circular paths. Means find the ratio of their radii. Compare the radii of their circular paths. Come on, do it. Compare the what? Radii of their what? Circular path. Just now we found the value, no? When a charged particle, same question extension. Same question extension. So what is happening here? So when they are moving, radius is mb by v cube. Exert the potential of b. What is the velocity? Root of 2e by m. So what is the radius now? Radius what is the formula now? Root of 2m ev divided by b cube. Or here, if it is any charged particle, you can write its charge as 2m cube. If it is electron, you can write E man. Any other charged particle, you write Q. So root of 2m qb by b cube. This is clear, everyone? Now radius depending on what parameters? If you take, see, magnetic field is same. Magnetic field is same. Potential difference also same. So radius proportional to root of what you can take there? M q divided by q square. When it goes inside root, it becomes q square. So this becomes proportional to root of m by q. Now for whom the value of root m by q is more, for them radius is larger. So ratio of radii. So r proton is to r deuteron is to r what? Alpha particle is equal to root of mass of the proton by charge of proton is to mass of deuteron by charge of deuteron is to mass of what? Yeah, alpha particle by charge of alpha particle. Now what is proton? 1h1 is called proton. Isn't it? 1h2 is called what? Deuteron. So isn't it? And alpha particle is what? Helium plus 2 entity is called what? 2 helium 4. If you remove 2 electrons, the helium nucleus is called what? Alpha particle. Helium nucleus is called alpha particle. Now come on, substitute the answer now. So what is 1h1 mass? If you take unit here 2 will be here what? 4 will be. So m by q. Charge is here 1, here 2. So take the ratio. This is if I take 1 unit as m, charge of proton as q. This is m by q is to root of deuteron will what? Don't what right? Charge is same. Okay, mass will be double. Charge is how much? Charge is same. Is to root of a mass of alpha particle how much? 2 electrons are removed, 2 protons and 2 neutrons. So how much? You can write 4. Yes or no? So 4m by what? Charge is 2. So m by q everywhere I can cancel. Root 1 is 1 is to root 2 is to root 2. That's what? 2 2s are no. Root 2. So 1 is to root 2 is to root 2. That means what is the meaning of it? Radii of deuteron and alpha particle is same. Radii of deuteron and alpha particle is same. This is root 2 times what? Radius of this particle? Proton. Radius of what? Proton. Okay? Clear everyone? What is it? Yes, sir. Yeah, this kind of models you see. Tomorrow we'll see Biot outline applications. Okay? Right. Thank you all.